Hold on. I look a mess.
I know what that feels like.
Yeah, oh my God. My son had soccer this morning, and then I accidentally, how do you call this? Volunteered for Saturday games. And because none of the parents wanted to volunteer, and I had coached my son's soccer team about a year ago, so I'm familiar with like the rules and everything. Well, anyway, I told myself I'm not going to volunteer this year. Oh my God, nobody wanted to do anything, so I'm like, okay, I guess I'm going to have to do it. So this morning we were rushing out the door to go, and long story short, I had a kid, granted I'm like volunteering, I had a kid started using bad language to the opposing team. And I'm like, you're 5, like, what are you doing? So the other parent volunteer from the other team was telling me, he's like, yeah, I had 2 of my players tell me that he said bad words to them. And I'm like, oh my God. So the head coach that's there to, try to make sure that everything's okay, he's like, just get your group together and just kind of talk about like, good sportsmanship, be kind, yada, yada. So of course the kids are just crazy, and I only had like 4 out of like my 8 team members, and I was telling them you have to be careful and not say bad things. Well, the kid was like, well, I was just being very defensive, and I'm like, look, I don't care, just make sure that you don't say anything. Well, the other coach overheard the grandmother of that kid and started being defensive, like, why is she calling my grandson out? And I was like, oh my God. I'm like, quit being defensive and own up to your grandchild's potty mouth, because that's not very nice. So I'm like, no, do not deflect to the fact that your grandchild has a potty mouth, and it's probably coming from you. So I'm like, oh my God, first game and already drama. So anyway, it's been a crazy day, and so yeah. But okay, so I just kind of like an update before Rocio comes on.
You're officially live. Hello, I'm Samantha Rosa Brodnitz, the Texas Ambassador for Young Women in Biology. Today, I'll be interviewing Dr. Rocio Vidana for Hispanic Heritage Month. Rocio, I hope your day has been wonderful so far. Are you ready to start the interview?
Yes, thank you so much.
Of course. Share a bit about yourself, like where you're from, where you currently live, and your occupation.
Okay, so I'm originally from Mexico City, but I'm currently residing in Houston, Texas. I am what you would call a bioinformatician or computational biologist. And what I do is that I use computational tools such as programming and analytics, big data and data science, to ask biological questions and leverage all the information that we already have to look for answers through our biological data.
That's fascinating. What's your educational background?
Well, my educational background is an interesting one. In Mexico, when I was about your age, they created a new undergrad program called Genome Sciences. Up to that point, I was planning to go to biology or biomedical research, but I had the opportunity due to one of my high school professors of learning about this new bachelor's. And we went to a presentation where I saw all these analytics and talking about biology and databases, and my mind was blown. And I was very lucky because I really didn't know that that was a thing. I liked a lot to do programming, but I thought, okay, well, I'll just go and do biology, and that will be it. Even in high school, like there was nobody really that told me like you actually do computer things, a lot of computer things in biology. Uh, but I had the opportunity, and after I finished my bachelor's, I came to Baylor College of Medicine. It's a really good school that has a very strong genetics department and a lot of graduate programs. I was very uh, I was very lucky because I participated in the equivalent to your to a summer camp and came to Baylor 2 years before, and was in Brendan Lee's laboratory. He's one of the genetics professors, and that opportunity gave me the really good tools to be able to put forward a strong application for grad school. I was interviewed, and thankfully I was able to come here. And here I did a short stint at the Human Genome Sequencing Center. At that point, I was very interested in cancer biology, and they were releasing something called the Cancer Genome Atlas, where it was just sequencing all these tumor normals. And we had like these big sequencing machines, and I was able to analyze some of that data. But I moved into another laboratory that was more wet lab focused, because they had a little bit of other data. Like smaller labs were starting to generate sequencing data and a lot of data. And there were also very interesting biological questions, but few people had the ability to feel comfortable using analytical tools to answer those questions. And so I jumped at the opportunity, and I was able to do a thesis in the Westbrook laboratory, led by Trey Westbrook. And we were studying mechanistic resistance to triple negative and HER2 positive breast cancer, to all types of breast cancer. And this was, I could see the real implications. It was really important to us to try to find alternative combinations of therapies or things that could like be brought forward at some point in the future for the patients, because the cancer is still like it's still a very difficult disease, and it's still it will still take a lot of people in the end. After that, after I finished my PhD, I was a little bit wishing for a more immediate application of my knowledge. So I joined Baylor Genetics, which is a clinical genetics company. I know the names are similar, but in here it is what we do is that if you had if you have a baby and there's a problem, an unfortunate problem, people will start trying to find if the condition is genetic. And there's genetic conditions we know of that we can test. And this provides the parents with a diagnostic certainty and the ability to, I don't know, look into it and manage the disease, or at least like figure out what's going on. So we go from very small panels of genes for targeted diseases that we know of to being able to sequence the whole genome of a patient and trying to figure out what happened or what are the possible changes or the possible mutations that a person could have. And this gave me the opportunity to see two things. Number one, it's that concept of the clinical application of many of these abstract and very cool concepts. But number two, it gave me the exposition of, okay, how does science in industry happen? So I've been doing that. And now I have been coming a little bit back more to my academic roots. I came back at the genetics department, and I have been doing everything from using the doing more of this genetic analysis to jumping into more machine learning, and now I'm trying to do some image analysis. So it has been like a very interesting stage at this point, I guess.
I'm so glad that you had that chance. Could you describe a typical day at work?
So a typical day at work for me would look, I would arrive if there's, well, pre-COVID, I would go to the office, I guess. I would have a desk with a computer set. I would use tools. Well, if there's a meeting or something, I would go to the meeting. But mostly it will be doing coding, reading papers, and trying to implement analytical algorithms on the computer. So if you see my computer, at some point, even my mentor told me that I was hacking something, because it will be like that, like terminal style with like the black background and some of the green letters going through. It's not that flashy, but it's mostly like typing commands and building programs. But there's a lot of interactions, like I would come talk to people, maybe use Messenger or something to be able to talk to people to discuss, to if I have questions, or think about, okay, what are we trying to do, or what question we are trying to do? Do we have the right data for it? How should I pose that question? Has the method to analyze it already been built somewhere? Can I use that method already? Looking into that documentation, seeing if I can apply things, and just going through the motions. But it's very much, it's like, usually a wet lab scientist will be at the bench, will be, or planning with their notebook, but my bench is the computer.
That's really cool.
Yeah.
Oh, sorry.
No. Go ahead.
Have you ever encountered any obstacles in your line of work based on race?
I haven't, at least not that I have noticed at the first chance. But what I have encountered is that I probably know like another 2 or 3 Hispanics and doing something similar to this. And only one of those is a woman. Whereas I have seen, okay, it's mostly a male-dominated field still, but the women that I have seen, like, let's say we are probably like a third of the people, but I could say that for every 100 non-Hispanic women, there is one of us. So it's unusual, especially in this field. It does get lonely, or like that's not something that you can share. Everybody likes the rosca de reyes and the pan de muerto and like the Hispanic parts. So I like to share those things, but it's very different from I don't know, like as I said, like I grew up in Mexico, and so I know a lot of my actually, like a lot of the people in the field that are Hispanics that I know are because they did the same that I did, like they studied and they came over. But I don't see I think I know only 1 or 2 other people, 2 other females here that I know that they studied and came here, but and are from here, and they are in the same field as me.
I hope we get more.
Yes, definitely. It's a very I would tell you it's a very interesting field. I know it's intimidating, and some people don't. I don't know if it's like they think it's like not sexy or something, but how do you say it? Like it gives you a lot of skills that are very transferable. You have to learn how to program, and I mean I'm not sure. I don't know if they teach you to the general high school population how to program, but knowing how to program or knowing how to interact with a computer today, it's an important skill in almost any discipline. From economics, politics, like even history and literature and philosophy, because actually like there's a lot of in those areas, like there's a lot of text mining of books, like there's computational analysis of books from any from any of those disciplines, things that you don't associate very strongly with computers. But biology, like biology is data, so it's a lot.
What do you like most about your job, and what do you find the most challenging?
Okay. One of the things that I like most about my job is the versatility. Like, I really have been very little impacted. I still can do pretty much 100% of my jobs during COVID. I mean, that's a benefit and that's not. But I've had the experience that I am traveling overseas or I am doing something and I'm able to like hop in and help with an analysis, like because I just need a computer. At the same time, that's terrible for like you need to be very disciplined in your work-life balance because you can spend like 12 hours, 16 hours. Like if you get like hooked, if you're hooked and you want the answer, you will be doing it. But it's also not like the healthiest thing. Like it's more, it demands more from you. Like because and a biologist cannot do experiments if they are not in the laboratory, right? They can read and they can do other types of things. They can analyze their data. They can they can read papers. They can think about it. But I can literally do the same things that I was doing in the office. The challenging part, it's a very changing, very fast-paced changing industry. What I learned in college to be genomics and the methods to analyze are literally like dinosaur methods by now. So I have had to be learning like at every stage of my career. I need to keep learning and I need to keep studying, and it's an endless learning circle. And that's the way it's going to be for the rest of my life. Like I remember artificial intelligence was such a nebulous concept when I was in college, but now it's like if you look at any company that is doing bioinformatics, there's a concept of artificial intelligence involved in it. So now you have to at least understand it, if not be able to implement it. So it's always constantly learning, and constantly learning. So you need to enjoy that part.
Yeah. How did you end up in your current position?
Well, this was I am currently working with Rodney Samajo in the genetics department, and he has a lot of very interesting questions about neuroscience and the ability to merge neuroscience questions from complex diseases. Image biology, he uses a lot of behavioral studies, and so we're trying to see if there's an ability to like put these two in an analysis pipeline, where we can use both the data from like doing mouse mutant, understanding how it's acting, and quantifying those errors. Like those things are already done by hand, but understanding if there's any genetic impact and doing it in a more high throughput scale.
Awesome. Is this what you thought you'd be doing in high school?
No. Like in high school, I had absolutely no idea. Like I tell you, if I had not gone to that talk, I would have gone straight into college, ignoring this very fundamental axis of my life. I would have found it like very quickly, but yes, I absolutely no idea. And you know, it's funny because the high school where I was, we had a technical component. We were going to learn programming, but the programming professor, the computer science professor, had no idea about any of this. because we were learning how to do some technical analysis, but we were learning tools that were more for architecture and engineering, because that was the physical sciences. Like the last year of high school in Mexico, it's like more of a specialized track. So you will go for physical sciences, biological sciences, administration, or arts, business or arts. And so we were learning more or less what the physical science guys were learning. But now that like we could have been learning all these other things. And I've seen now that in high schools in the United States, like I even know there's a couple of papers made by computational analysis by guys in high school that get even submitted, and it's a legit paper, and it's so cool that like this is being brought, albeit slowly, it's being brought more to an earlier age to the knowledge. Like I know that when I told my parents I want to study genomics, they were like, "What?" And now and then when I say, "Oh, I do genomics or whatever," a couple of people have told me like economics, and I'm like, "No, not really."
What made you interested in biology?
My mom is a medical doctor, so since the very beginning, I was very um, interested in, or very exposed to the human body, the concepts of disease, and so that material was easily available around my house. And I mean, my mom was something that she usually commented, so I was fluent enough in the language to be able to like look at things. But I also was very interested in, well, I liked the science class from the very beginning, since elementary school. But I guess I tell people that like I love dinosaurs. Like I still like look at dinosaurs and read about paleontology and like go. I mean, I'll go to the Houston Museum of Natural Science and just like get lost in the dinosaur area. And I went when they opened. It was like just amazing. But I joke with people that like I ended up in genomics because I watched Jurassic Park when I was like 7 or 8, and that's where the concept of genetics was introduced to me, when they were saying that they could get dinosaurs. So it just sounded like the most obvious thing that everybody should do, like study genetics and get your own dinosaurs. Still haven't figured out that part, but we'll see.
That's so great. What's your best piece of advice for young aspiring biologists?
I think it's well, number one, it's there's these opportunities. Number two, do not be intimidated. Like you are not bringing you in, or like do your study hard, and don't be intimidated. You belong in the place. Like don't be scared. You're as smart as everybody else. You can be like the leader in anybody else, and don't get disappointed in it being challenging. Science has a way of not being forgiving with anybody. Just makes everybody's lives difficult during grad school and stuff. And never be afraid of trying new things, even if you see that the field is like not very diverse. Just don't care, go for it. Yeah, I think it's just follow what you like, listen to people, build a community, get advisors early on. Yeah, just keep going. There's a lot of support for the community. Even if we don't are not as many, or are not seen as around as much. Many of the people that I know are successful because we just go and do it, and we're not like waiting for permission or anything. No, just go for it.
Well, thank you so much for your time today, Rocio, and thank you for your contributions to the field. Have a
Thank
lovely
you.
day.
Thank you. Thank you, Samantha. I really enjoyed talking to you.